This lesson is on the product of powers property. The product property is just talking about what we do when we're multiplying exponents and what we do with those properties. Now, if we're looking at this, our essential question or our objective is how can you use inductive reasoning to observe patterns and write general rules involving properties of exponents? So we're going to look here at trying to figure these out. Like we have 2 to the second power times 2 to the fourth power. If I was going to write that in repeated multiplication form, I would have the 2 times 2 right there, and then the 2 times 2 4 times right there. So if we count that up, we just have 2 to the sixth power, because there's 6 of them. Now let's look at this next one. We have negative 3 to the second power and negative 3 to the fourth power. So let's write that out in the repeated multiplication form. If you look here, we've got the negative 3 squared in the red, and then the negative 3 to the fourth in the green. So if I count those up, I've got negative 3 to the 1, 2, 3, 4, 5, sixth power. Well, let's look at 7 to the third times 7 squared. Following our same rules, 7 cubed is in the yellow, 7 squared in the orange. Count them all up. Keep the base the same. 1, 2, 3, 4, 5. 5. 7 to the fifth power. Go ahead and pause the video and see if you can fill in the rest of this on your own. If you did it correctly, you should have had 5.1 to the ninth. Negative 4, remember to keep the parentheses around the negative part. Negative 4 to the fourth power. You have 10 to the eighth. And 1/2, again with the parentheses around the 1/2, to the 10th power. Do you notice something that we look here? If you notice, if you take the 2 and the 4 and add those, you're going to end up with the 6. 3 and 4. Sorry, that's 2 and 4. You get 6. 3 and 2, you get 5. 1 and 8, you get 9. Notice that pattern? So what we're looking at here is that if we add the exponents when the bases are the same, when we're multiplying, you just add them. What this is called is powers property. So product of a power property. In other words, we multiply powers with the same base. Remember, the base is the same, and then we just add their exponents. If you're looking at this as far as number goes, so you've got your 4 squared times 4 to the third. So you keep the base the same, the 4, and just take the 2 plus 3, which is 5. In algebra terms, that would be like a to the m times a to the n, and that's going to be a to the m plus n. Now another rule that you're going to learn is the power of a power rule. That's when you have an exponent that's raised to another exponent. So to find the power of a power, you end up multiplying the exponents. So like here we've got 4 to the sixth, and that's inside the parentheses, raised to the third power. So you're going to take the 4 and take the 6 times 3. So 4 to the 18th power. And then the final one is the power of a product rule, property. That's when you're going to find the power of a product. Product is two numbers that are being multiplied together. So to find the power of each factor and multiply. If you have 3 times 2 inside the parentheses raised to the fifth power, it's 3 to the fifth times 2 to the fifth. Which, yeah, you could probably do this easier with it being numbers, but we're preparing you for the algebra stuff where you're not going to have numbers. You're going to have letters, like this AB to the M power is A to the M times b to the m. So if we're looking at our examples, multiplying powers with the same base. So this is where the base is the same. First thing you want to do is, by the product of powers property, we just add the exponents. And then you simplify. 4 plus 5 is 9, so you get 2 to the 9th power. Here, we're going to rewrite the negative 5 to the first power. Whenever you have a number that doesn't have an exponent, that means that it's being raised to the first power. That way we don't accidentally forget to add in that extra 1. We rewrite that. And now we keep our base the same, that negative 5 with the parentheses still around it. Remember, it makes a difference whether the parentheses are around or not. And we're again still just multiplying, so we add the exponents. 1 plus 6, according to the product of powers property. And we end up with negative 5 to the 7th power. That's simplify. If you notice, this is kind of setting you up, you'll find out for geometry later, is that it's kind of doing the action over here in this column, and then over here it's explaining it. Why did I do that? It's because of this rule. So again, we've got x to the 3rd times x to the 7th, according to the product of properties. The product of powers property, I add the exponents. Simplify those and we get x to the 10th power. That's example 1. Now example 2, we're moving on to finding a power of a power. Remember, when we find the power of a power, we're going to end up multiplying those powers together, those two exponents together. So we keep the base the same. So we've got our 3, and then we've got 4 times 3 according to the power of a power property. And then we can simplify. 3 to the 12th. 4 times 3 is 12. Now here we have w to the 5th raised to the 4th power. Again, according to the power of a power property, I can take w and then I can take the 5 times the 4. 5 times 4 is going to give us w to the 20th. That's when we simplify. Now, if we're looking at our third example here, we're finding the power of a product. Remember, a product is when you got more than one number being multiplied together, whether it's 2 numbers or whether it's a number and a letter or a number and 2 letters in the case of the b. But we have 2x raised to the 3rd power. If you remember, according to the power of a product property, I can take 2 to the 3rd power times x to the 3rd power. Or you might say cubed too. It would be 2 cubed times x cubed. But we really don't need to have that multiply symbol in there, so we can just simplify. We know that 2 cubed is 8, because we can find that. We just don't know what x is. So then that's just going to be simplified down to 8x cubed. Now on letter B here, we've got 3xy all squared. So again, according to the power of a product property, I'm going to take each one of those terms and square it. So I've got 3 squared times x squared times y squared. Well, we know 3 squared, that's 3 times 3, so it's just 9. So then we can simplify and get 9x squared y squared. So let's look at example 4. This is where we can have some real-life applications. A lot of you are pretty interested in computers and doing computer programming, and making games would be another thing there. You're dealing with computers and how to program them and things like that. But we're looking here at a gigabyte of computer storage space. It's 2 to the 30th bytes. The details of a computer are shown. How many bytes of total storage space does the computer have? So it tells us that local disk C has free space of 16 gigabytes and total space of 64 gigabytes. So what we're going to do here is the computer has 64 gigabytes of total storage space. Notice that you can write 64 as a power of 2. 2 to the 6th power. Now we can use a model to solve the problem. The total number of bytes is going to be equal to the number of bytes in a gigabyte times the number of gigabytes. So we know that the number of bytes in a gigabyte was 2 to the 30th power, which we were given up here in our word problem. And we know the number of gigabytes that we have is 2 to the 6th power. Now again, according to our product of powers property, all we have to do is take that 2, keep the base the same, and add the exponents. So we've got 30 plus 6, so you're going to end up with 2 to the 36th when you simplify. The computer has 2 to the 36th bytes of total storage space. So the correct answer here would be B. Now you're going to go ahead and try the problems on your own. So finish the do your own. So finish the on your own section. Show me your notes so that I can count those as being done. Do your assignment that is on Clever, and then finish any missing assignments that you have.